try to solve a physics problem that uses the second Newton's second law. So the problem is that you throw a ball at a 45-degree angle. So here's a person standing here, and there's a ball in his hand, and he launches the ball at a 45-degree angle. We're trying to find the force of this throw, alright? So first, what we first need to do is we need to know what we have as a given. So we know that force equals mass times acceleration based on Newton's second law. Then we know the mass of the ball is 64 kilograms. And we know the distance the ball traveled is 6 meters, and the time it took to travel was 1.1 seconds. So right now, in order to find the force, we need the acceleration. So in order to find the acceleration, we're going to use one of the big 5 equations, where the position equals the starting velocity times time plus 1/2 times acceleration times time squared. Okay? Well, the starting velocity is going to be 0 if I'm holding the ball before I launch it, right? So this is just going to turn out to be 0. So we can just cancel that out. We know that the x stands for distance, by the way. We know that equals 6 meters, and we know that this now equals 1/2 times acceleration times 1.1 seconds squared. 1.1 seconds squared is 1.21 seconds squared times the acceleration times 1/2 equals 6 meters. Now we can get rid of the 1/2 by multiplying both sides by 2. So 12 meters equals the acceleration times 1.21 seconds squared. Alright? Now we can solve for A by dividing both sides by 1.21 seconds squared. So we divide both sides by 1.21 seconds squared. 1.21 seconds squared. Alright, and we end up with 9 sorry, I already did this problem here. 9.917 meters per second squared. Okay, which is our acceleration. So now we can write here.
So I think we've got all the forces we need. Now we just
acceleration.
Which of those forces?
9.917 meters per second squared. Okay. Now we also know that we can imagine that the force of the ball equals 2,000 newtons. Okay? So we can say that this force is 2,000 newtons. And the angle it's being thrown is 45 degrees. Okay? And if this is the ball right here, we also have the force of gravity, which is going to be F of G is going to be negative 627.2 newtons. Okay? So now we're not quite done yet. We don't know the net force for this time. So if we have this vector, which is 2,000 newtons, and we know it's 45 degrees, we can break this into 2 separate vectors. Alright, this vector right here is actually the normal force. And if we subtract this and the force of gravity, we will know the net force of the throw. So in order to find that, we have to use trigonometry. So the sine of 45, let's give this value x. The sine of 45 degrees equals x over 2,000. So if we do 2,000 times the sine of 45, we will get what x is. So 2,000 times the sine of 45, and that is 14.21 newtons. Okay? So now if we subtract this value minus the force of gravity, okay, so that's 14.21 newtons minus the 600 negative minus, well, we can do a net, so minus 627.2 newtons. That is going to equal 787.01 newtons. So now we can do this triangle again. Alright, we know that the force is 2,000. No, we don't know the force is 2,000 anymore. So now we can also find this value right here to make our new vector. So that would be the cosine. So instead of sine, we'll just do the cosine. So the cosine of 45 equals xy over 2,000. Alright, so 2,000 cosine 45 equals, well, it's the same value since it's a 45 degree triangle. So now we know that the bottom is going to be 14. Come on, work with me. 14.21 newtons. The top is going to be 787.01 newtons. And so we can just use Pythagorean theorem to find out what the net force of this throw is going to be. And wait 1 second. And take the square root of this answer. And the net force is 1,618.44 newtons. So that's how much force went into that throw when the ball was launched from my hand. Thank you.